So the next lesson in our slot is lesson 2. And that's going to be slotting with even, it says it right at the top of your packet, with even powers underneath the radical. So, looking at the very first thing, remember we talked about perfect squares, and I wrote a list, and I said 1, 4, 9, 16, 25, 36. Well, I'm going to write you another list, and that list is a to the second, a to the fourth, a to the sixth, a to the eighth. What am I doing? A to the 10th. These are all even powers, right? Well, guess what? These are also perfect squares. So this list of numbers are considered perfect squares, just like all the other numbers that we've been talking about are. Why? Why do you think only even powers, Sophia?
Because when you multiply powers, they just add together.
Yeah, because when you multiply powers, you just add them together, right? So what did I square to get a squared? A times a. What did I square to get a to the fourth? Yes, a squared times a squared. What did I square to get a to the sixth? A to the third times a to the third. Here's, watch, I'm going to write it differently now. What did I square to get a to the eighth? Yeah, a to the fourth to the second. Then I took a to the fifth to the second. Then I took a to the sixth to the second. So however you look at it, whether you look at it as add and keep the base, or keep the base and add, or keep the base and multiply if you write it this way, aren't these all perfect squares? So every even power is a perfect square. Every single one of them. Okay? So now, the trick is, how do you find the square root? So if I say, what's the square root of a to the 20th? You just divide the exponent by 2. The square root of a to the 20th is a to the 10th, because that's what I multiplied by itself to get a to the 20th. What is the square root of x to the 50th? X to the 25th. You literally just divide it by 2. Okay? So the square root of r to the 200th is r to the 100th. Okay. Caution. Red flag. For some weird reason, as soon as I teach this lesson, and I know why, people start to tell me that the square root of 100 is 50. What are they thinking? That they're using the property of finding the square root of a perfect square exponent, and they're applying it to an actual number. You know that 50 times 50 is not 100. The square root of 100 has not changed. It's still 10, so don't tell me that it's 50, okay? So you have now 2 separate rules, and you have 2 separate compartments in your brain that you have to know. If it's, watch, if it's the square root of 100, this will clear it up for you. So the square root of x to the 100 is x to the 50th, but the square root of 100 is 10.
So if there's exponents, then you take it.
Yes. If it's an exponent, then you can, if it's an even exponent. Tomorrow we're going to talk about odds, which is a whole new rule. But if it's even, you take half of it. If it's a big coefficient number in the base, you know that you can't take half of it. You know that. Okay, you've known that for a while. So, here's the general, here's what's always tricky then. What do you think people want to tell me that is? That x to the 8th is the answer, but they have square roots on their mind, so they tell me that it's x to the 4th. And no, it's not. It's half of the exponent. So do you see how this could play tricks with your mind? So don't let it. Yes?
What if it had a coefficient?
That's what we're going to do next. So just to make this fun, William wants to know what 16x to the 16th would be. Yes. It would be 4, because that's the square root of 16, and an x to the 8th, because that's half of, and that That example right there is the best thing I could have given you to kind of help you make the distinction between the two.
I'm just curious, is it possible to have like decimal exponents?
You can, and it gives you a whole, yes. But for what we're doing in Algebra 1, we stick, but yes. Oh, there you could have, there's something where you can have x to the nth, or 2 to the x power, and it's the exponent that changes, and that's a different kind of graph. There's all kinds of crazy things. You could have negative exponents that we know about, we've done. Okay, so are we good on this right here? Talking about even powers, yeah. So then my next question, and William kind of hinted to it, is what would I do if I had, like 25x to the 16th? I know I just did 16, but so then that would just give you have to take the square root of the 25, and here's how you could look at it, guys. Remember how you can separate things? So if this to you looks too confusing and you want them to each have their own separate radical, now you look at it as, okay, the square root of 25 is 5, and the square root of x to the 16th is x to the 8. Go for it. I'm telling you that if these are all perfect squares, you don't have to show any work. You go right to an answer, and I don't tell you that often, do I? Okay? So, because there really isn't much to show until you get to a problem like this. What's different about this one? It's not a perfect square. Well, the 20 isn't. The x to the 50th is, right? So all you're going to do, and this is where the real stuff starts. So I really want you to kind of watch the steps that I take to solve this. Remember how I said you don't have to write it out up here? Because it was a perfect square. Now that you have some work to show, watch how you're going to show it. You're going to take that 20 and you're going to make it the square root of 4 times the square root of 5. And I know you are so tempted right now to just take that x to the 25th out right now. Don't do it. I will keep saying it. You'll see why. You'll thank me later. So the first step in breaking any radicals down, and when you simplify them, is to just separate everything. Separate that 20 into the 4 and the 5. Separate that x to the 50th. Keep it that. And then the second step is then go through and either take out what the perfect squares are or leave them in if you can. You're doing that all in one step. So I'm working from my way here. Is this a perfect square? It can be taken out. This is a 2. Is this a perfect square? No, it's going to stay. So I circle it. So either circle it or slash it. Is this a perfect square? Yes. Pull it out. This is x to the 25th. So I took this 2 and this x to the 25th, and the radicals always go at the end. So your answer for that is that. Some will get left taken out and rescued if they're perfect squared. Some won't if they're not. Let's do this one. Negative, we're going to talk about, make sure you don't forget about that. 48 x to the 60th, y to the 150th. Okay? Well, I'm looking at 48, and you may be thinking 6 times 8, but then you're going to have to turn around and break 8 down. So, anybody know what 48 divided by 3 is? 16. Okay? So, watch what I do. Bring that negative sign along, because if you forget it, it's going to be wrong. 48 is the square root of 3 times the square root of 16 times x to the 60th times y to the 150th. You have to do that. Then I go through and either circle or slash. That's what I call it. Circle it if it stays, slash it if it's a perfect square. So this is going to stay. Nothing can come out of that. 16, the square root of that is 4. The square root of x to the 60th is? Yep. And the square root of y to the 150th is y to the 75th. Then I go back and my eyeballs look for any circles, because those are the things that have to stay. And those things go at the end. Think you got it? Okay, this really is not that bad. So I want you to try this one. 125 a to the 10th, b to the 20th, c to the 30th. Okay? Show that middle step. So you got one line of work before you can get to your answer. Yeah, that's a 10. So that's what your work should look like. Got it? Okay, this is not bad, is it? Okay, so then on lesson 2 in your packet, even powers, I want you to look at this. And I know what you're thinking. Holy cow, 9 through 44, that's so much. I want you to look at the top section. 100, 144, 81, 169, 121. They're all perfect squares. You can look at this answer and put the answer, and these top sections can be done in 5 minutes or less, right? However, when you get to the bottom section, 30 through 44, 27, 32, 48, they're not perfect squares. So tomorrow when I check, I don't really feel the need for you to copy this problem on a separate sheet of paper just to write the answer right next to it when you can fit it there. However, you are going to have to show your work separately for this section. Do you understand what I mean? So, do I want all this work crammed in this tiny space tomorrow? No, I won't even look at it. I want to see it nice and neat. You guys got to start. We're getting to the point where there are problems that we're going to have to do where you're going to see me turn my paper sideways because it takes up so much space that if I do it this way, I won't have room. So, if you want to talk about keeping yourself organized from day one with this stuff, because these problems are going to get nutty, take the time to keep yourself organized like that.